So in this video we'll be looking at how to find the quartile values and the interquartile range from a list of numbers. Now the quartiles is a set of data represents the markers of the bottom 25%, the median, which is around about the 50% mark, and the top 25%. And one of the main purposes of finding the quartile values is to calculate the interquartile range, or the IQR as we abbreviate, which is a calculation used to measure the spread or the consistency of a data. So the interquartile range is more of a sophisticated way of measuring spread, whereas before the lower one would be the range. And it's also used to then go on and draw a box and whisker diagram, or as it's sometimes known as a box plot. Now, using the interquartile range as a measure of spread. Now, the interquartile range, as I've briefly mentioned there, is a better calculation of spread when the numbers in the dataset are very spread out. So if you find that in your dataset there are some big numbers or some small numbers, and you want to look at a more accurate way of looking at spread, then the interquartile range would give you a better calculation. Now, the interquartile range gives a range of the middle 50%, and by doing so, we ignore any small or large numbers that may distort the actual picture or analysis of the data. Now, the smaller, and this is only when you are comparing two sets of data. Now, the smaller the IQR, the more consistent or similar the numbers are, and the bigger the IQR, the more varied or different and inconsistent the numbers are. Now, obviously, what determines a small interquartile range and what defines a large interquartile range will be when you're comparing it to another set of similar data. So for example, if we imagine that a group of 14 family friends went to a restaurant to celebrate a birthday, and you can see there that we've got a list of ages of those 14 people. Now, if we work out the average age of those 14 people, it works out to be roughly around about 25.6 years old. And if we were to look at the age range of that party, it's going to be somewhere between 2 and 86. Now, obviously, if we're looking at the actual range, then the range would be 84 years. But if you actually look and take a closer look at the actual numbers, you can see quite sort of vividly that the party of whoever's being celebrated is, as you can see, we've got a lot of 15 and 16-year-olds in there. So you would expect whoever's birthday to be around about 15 or 16. Now, you can also see that bar of about 4 people, that again, majority of the people in this party are around the ages of 15-16. So you would expect a more average age to be closer to 15-16 than the actual calculated mean, which is 25.6. And this is why we talk about looking at analysing the data. You can see clearly that the person who is 2 years old and the 3 people who are 34 and particularly 82 and 86 are massively distorting that data, massively distorting the calculations, I should say, of that data. And if you were to actually remove either the young people from that group and the old people of that group, you could there find that the average age, whether it be whichever average you use, will be more realistic as a calculation. And also the age range would be more sort of accurate in accordance to the picture. So what we kind of do is, for example, if I just get my pen here, so if I was to eliminate, let's say, the youngest 3 people and the oldest 3 people, you can see that the age range is going to be more of a general picture of 15 to 16. And this is what the interquartile range actually does. It eliminates any sort of the lowest 25% of the results, the highest 25% of the results, giving you the middle majority of 50%. And like I said, this is one of the advantages of using the interquartile range as a measure of spread, because it eliminates any high or low values you may have. So in terms of finding the interquartile range from a list of numbers, now in order to find the interquartile range, we must first order the data from smallest to largest. Now you can do it the other way, but it makes more sense for us to do the smallest to largest. And this is very, very similar to working out the median, which you have to actually work out as well. So to work out the interquartile, now the median isn't really essential to work out the interquartile range. It's just one of those things that are more commonly asked when you are working out the interquartile range, and that's pretty because it's the 50% marker. Now the lower quartile is the 25% marker and the upper quartile is the 75% marker, and from this the interquartile range is calculated by taking away the upper quartile value away from the lower quartile value. Now the key thing to remember with regards to this is that the upper quartile is not 75 and the lower quartile is not 25. It's just a case of whatever those values are. And I would definitely strongly recommend of making a note of that. So let's just pop around that. So in terms of the method now, obviously when we go through some examples, hopefully we will kind of go through what each of these steps actually are and try and get them all in there. So, and again, I would strongly recommend you making some form of notes on these 5 steps. Now obviously there is a different method you can use, but I tend to find that when you've got a list of numbers, I would say no more than probably about 11 or 12 numbers, then this method you might find easy to work with, and we'll later on in the video we'll show you how to work out the interquartile values and quartile values when you've got, let's say, quite a large data set, or if your data's in a table. So the first thing you want to do is order the data from smallest to largest. Then you want to find the median, which is the middle number, which you should have already worked out. And if there is a number in the middle, put a circle around it, and if there are 2 numbers in the middle, then simply add them together and divide by 2. And then what you then want to do is then draw a line in between those 2 numbers that are in the middle. And again, if that makes absolutely no sense, I will explain what that means. Now the lower quartile is the middle number on the left hand side of the median circle number or line, and the upper quartile is the middle value on the right hand side of the median circle number or line. And then from that we can then calculate the interquartile range, which is the lower quartile, take away the lower quartile. So let's now put that into practice with a question. So in this first example we have a set of numbers and they've nicely been ordered for us already. Now the key thing to note in this is that we have got an odd number of data. Now usually when you have a list of numbers, you're either going to have an odd number of numbers or an even number of numbers, and the method is slightly different as to which one we're going to go for. So the first thing we're going to look at is the odd number. Now in this I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So from this I can see straight away that 29 is the middle number and that represents the median. Now the lower quartile is going to be the middle number on the left hand side. So this here is the left hand side of the median. Now as the median is a physical number, I'm going to exclude that from that, and I'm just, that's hence why I've put a circle around it. Now the middle number is going to be here, so the lower quartile is between 23 and 24, so it's going to be 23.5. And the upper quartile, which is, if I look at all of these numbers that are on the right hand side of the median, I find that the middle number is going to be between 35 and 39, which is going to be 37. So the upper quartile is 37. And from this I can work out what the interquartile range is, which is going to be 37 take away 23.5, which gives me an answer of 13.5. So just to round up, I've got my median value of 29, I've got a lower quartile of 23.5, I've got an upper quartile of 37, and my interquartile range is 13.5. Now you kind of know when you've done something right when those numbers should be in order, in sort of numerical order. So your lower quartile should always be the smallest, my median should be the middle, and the upper quartile should be higher than the other 2 quartiles. Now median is sometimes known as a quartile, it's usually known as Q2 or the second quartile, but we can go from there. So let's have a look at another example. So this time what we've got is we've got an even set of data. Now the first thing you should be able to spot is the fact that we have got the data is not ordered. So the first thing we need to do is order the data. Now from this what I'm going to do is not play hangman, is I'm just going to create some dashes just so that's easy for me to order. So here I've got my smallest, which is 8, and then scouring the data I've got 16, I've got 19, then I've got 23, and then 24, and then 26, and then 32, then 35, 37, I've got 42, 56 and 62. So that's the first thing I've done. So next thing, let's count how many numbers we've got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here my median value is going to be between these two numbers here. So my middle two numbers are 26 and 32. And again, if I work out the middle number between those two numbers, now again, if you're not sure or struggle to work out what the middle number is going to be, just simply add the two numbers together, in which we get 58, divide it by 2, and we get the answer of 29. So here my median value is 29, which I'm just going to make a little note on the side. Now you can see here that I've got a line that represents the median value. So now what I need to do is work out what number is in the middle on the left hand side of that line, and you can see that the middle number is going to be between 19 and 23. So again, if you're not sure what the middle number is, add the two numbers together and divide by 2, and we get the answer of 21. So the lower quartile is 21. And then if I do the exact same this time on the right hand side, so again the middle number is going to be between 37 and 42. So again, if I add those two numbers together, I get 79, divide that by 2, and I get 39.5. So the upper quartile is 39.5. And then the last thing for me to do is work out what the interquartile range is. So the IQR is going to be 39.5 minus 21, which is going to give me 18.5. So the IQR is 18.5, and there is my quartiles calculated. Now in terms of find the quartiles from a large set of data, now let me just make that a little bit bigger just so we can see. And you can see in your notes. There we go. So in terms of finding the quartiles and the IQR from a large data set, now obviously if you've got, now the previous example was not too bad because we only had, let's say, like 12 and 13 bits of data. Now if you had data that was in the 40s or 50s, then you might find that that method, particularly if they're not ordered, you might find it's going to be very, very difficult and very time consuming for us to do that. Now obviously there's no workaround of ordering your data. That's something that you have to do to work out the quartile values. Now so if that is the case, so though the above method is pretty quick and easy, it can be very time consuming to use when you have lots of numbers in our list of numbers. An alternate method of finding the quartiles is by finding which position the quartile number is in, and then counting to find this number from the list. Now from that, just change that to from. Now when the total number of numbers in the data list is n, to find the position of the lower quartile, then all you need to do is, if n is the total number, so 13 bits of data, 14 bits of data, so n would be 13 and 14 respectively. So to find the lower quartile position, you just divide that total number by 4. If the answer is decimal, you round up, and if the answer is a whole number, you add 0.5 to it, and then that answer would be your position of where in your list of ordered numbers would your lower quartile be. Now to find the median value, we use n divided by 2, so divide the total by 2, and if the answer is a decimal number, you round up. If the answer is a whole number, you add 0.5. And for the upper quartile, we use 3n divided by 4, or 3/4 times n, and again, if the answer is a decimal number, you round up. If it's a whole number, you add 0.5. Now from that, what we can then do, and a key thing to remember here is that using these formulas only tells you position of the quartile, not the value of the quartile. And again, if that makes absolutely no sense to you at all, do not worry, because like I said, I will explain it in an example. And like I said, it's worth definitely writing this in your notes. Like so. So moving on from this, let's have a look at an actual set of data. So for example, here we've got, and first can stop messing around the computer, there we go. Let's just make these numbers a little bit bigger for us to see. And we've got 55 bits of data. And what I want to do is now work out what the actual, where the lower quartile is. Because as you can see, it's in a bit of a table, and now I want to work out where it is. So to find the lower quartile, what I'm going to do is I'm going to do 55 divided by 4. And if I do 55 divided by 4 on my calculator, it gives me an answer of 13.75. So 13.75. Now because that is a decimal number, what I'm going to do is I'm going to round that up to 14. And it tells me that the lower quartile is my 14th number in the ordered list. So from this, all I then need to do is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my lower quartile is 25. And what I'm going to do is I'm just going to kind of colour that in just so I can see that that is the lower quartile. Now to work out the median, what I need to do is do 55 divided by 2, and again that's going to give me an answer of 27.5. And again, because that is a decimal number, I'm going to round that up to 28, so the median is my 28th number. So again I'm going to count, so if 25 is my 14th number, so that's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 39 is my median value. And again, let's just highlight that using a different colour. And then finally, to find my upper quartile, I'm going to do 3/4 times 55, or 55 times 3 divided by 4, whichever floats your boat, times 55, and I get an answer of 41.25. And again, what I'm going to do is, because that's a decimal, I'm going to round that up to 42, so it's my 42nd number. Now, to make my life a little bit easier, I know that there's 44 is going to be here, so my 42nd number is going to be here, so that's 64. And let's just highlight that, and let's say this colour here. So therefore, once I've got my quartiles, the interquartile range is going to be 64 minus 25, which gives me, again, 64 minus 25, which gives me the answer of 39. And there we go. Now the key thing to remember here is that although we calculate the median second or first, that it's always the lower quartile and the upper quartile are the values that we use to work out the interquartile range. And it's always good practice for you to always make sure that your labelling and your answers are clearly seen, so that the marker or whoever's assessing your work, whether it be a teacher or an examiner, can see exactly where you've done and what calculations refer to what. So let's have a look at an even set of numbers. So again, here we've got a new total of 70. And let's just highlight that. So to work out the lower quartile, what I'm going to do is I'm going to do 70 divided by 4. And again, 70 divided by 4 is 17.5. And so from that, what I'm going to do is, because that's a decimal, I'm going to round that up to 18, so it's my 18th number. Now from this, and let's just count, we'll have the range of 2, 3, 4, 5, 6, 7, 8, 9, 10. So then from this, I can see that my 18th number is going to be 23. Then to work out the median, I do 70 divided by 2, which is 35. Now because this is a whole number, I'm going to add 0.5 to it, so that gives me 35.5. So what that tells me is that my median value is between the 35th number and the 36th number. So the median is between let's just get rid of that equal sign. The median is between the 35th and the 36th number. So here we've got 30. So looking at my 35th and 36th number, it's going to be between these two here, which gives me an answer of 51.5. And finally, to work out the upper quartile, what I need to do is 70 times 3 quarters, or 3 quarters times 70, or 3 times 70 divided by 4. And if I just quickly work that out, I get 52.5. Now because that's a decimal, I round it up to 53, so it's my 53rd number. And again, counting through the data, so I've got 10, 20, 30, 40, 50. My 53rd number is 70. And there is my upper quartile, so giving me my IQR value of being 51, or shall I say 70 minus 23, which gives me 47. And there is your answer. Now obviously if this data was in a frequency table, then again what I'd need to do is work out the positions, and then from that table I wouldn't necessarily need to rewrite the list of numbers as I've done here, because obviously if you've got 70 bits of numbers, it might take you, certainly will take you a long time to do, but this you might find is a quicker way. Now this also works when you're working with a shorter list of numbers, but I would say if you've got numbers around about the 13, maybe 14 mark, you might find it easier to go the route of ordering numbers up, putting a circle or a line where it represents the median, and then using the above method. I would only really go for using the, let's say, divided by 4, divided by 2, and divided by times them by 3 quarters, I should say, of working out the quartiles when you've got a larger set of numbers. Now I would strongly recommend that you practice this technique, in which there is an attached worksheet for you to have a go at, and obviously a set of answers for you to check your answers with as well. And obviously the next step from this will go on to drawing and representing the data in the form of a box and whisker diagram or a box plot.